All right, so I'm just going to go over factoring four terms by grouping. I have videos on different types of factoring and like using grouping if you have three terms, but I thought I'd do something that's focused specifically on the four terms, just so you have an idea of the process, and then that way when you watch the factoring by grouping for three terms, you already kind of have an idea of what's going on. So grouping is a specific technique that we use where we have four things and then we group things in pairs. You can do grouping with more than four terms. You could do five, so you can have groups of like two and three, but you're grouping things together. But when we talk about four terms, we're grouping them in pairs. We usually group the first two things together, the last two things together, and what allows us to do this is the associative property. So we're just putting parentheses around things. And then the factoring by grouping is where you actually do stuff and factor. So usually when you factor by grouping, if you have four things and they don't have a greatest common factor, or there's not any other way that you can factor, you usually try to factor by grouping. And so that's where we take the four terms and we pair them, and then those pairs are called binomials because there's two of them. And then what you do is you factor each of those smaller groups, and then you factor the whole thing. So you're like factoring multiple times, but it's a way to kind of get around of I see four things and there's nothing in common with all of them. So I've kind of tried to put a sort of a procedure here, something for you to follow. So you start with four terms. So I've just labeled them term 1, 2, 3, and 4. And then you group them in pairs. So we usually do the first two and the last two. And then you factor the greatest common factor out of each pairing. So each pair may have a different greatest common factor. They don't have to match. So that's why I've labeled them as GCF1 and GCF2. And when you factor out the greatest common factor, you're basically dividing it out of each term. So that's why I've also written it with the division. And when you simplify the parts that are in parentheses, when you actually divide it out, you're going to get a binomial, and you should have, if everything works well and you did it correctly, everything in parentheses, both binomials should match. So you'll have two different greatest common factors, but what you end up in parentheses matches. And so then what we're doing is we're factoring that out, which leads us to that binomial being in front, and then the second set of parentheses results in just your greatest common factor. So you end up with two things multiplied together when you go through this whole process. So we're basically taking four terms. Oh, I did not mean to do a highlighter. And we're turning it into two things multiplied together, just like when you're factoring like a trinomial. So we're taking four things and we're trying to get them to two things multiplied together. And that's the goal, and you follow these steps. So I've got a few examples here to kind of work through the process so you can see. And my last example is going to be a little tricky, just to show you that, you could end up with some tricks. So we're going to factor 4x cubed plus 3x squared y plus 4xy squared plus 3y cubed. So looking at this, there's no greatest common factor. There's no number that I can divide out of all these terms. They don't even all have the same variable because the first term is missing a y, the last term is missing an x. So I can't factor anything out. So this is where I'm going to go into grouping, and I'm grouping the first. I've just put parentheses around the first two and the last two to group them together, and then you want to find the greatest common factor of each pair. So you're going to have two different values for your greatest common factor. Sometimes they match, they usually don't. So the first pairing, I have 4 and 3, there's no number I can divide out of both of those. But if I go on to the variables, I have an x cubed and an x squared. So they both have x, and you take the smallest exponent, so that would be x squared. And then I don't have a y, but I have a y, so I can't divide y out. I move on to the last two. Again, 4 and 3 don't have a number in common that I can divide out. I can't take out an x because the 3y cubed doesn't have an x, but they both have y. And so I want to factor out the smallest exponent, so that's going to be the y squared. So I'm going to rewrite these, and I put my greatest common factor in first, in front, and then I'm dividing each term, each pair, by the greatest common factor. And I usually don't show this step, but it's good practice that you get used to using the rules of exponents and you understand that dividing. So I did that for the first one. Now I want to also do it with the second one. You have to have a plus, and then I move on to the next greatest common factor. And then I take that pair, divide each term by their greatest common factor. So I've got two separate factoring things going on here because they have two different greatest common factors. And so I'm going to simplify inside the parentheses. So I have 4x cubed over x squared. So I'm going to have a 4 when I divide that. And when you have exponents like that, you subtract top minus bottom. So 3 minus 2 is 1. So I'm left with a single x. And then I go to my second fraction that I have. I have a 3. And then my x squared over x squared, those completely cancel because 2 minus 2 is 0. So there's no x at all, but there is a y. So when you factor out an x squared, you're left with 4x plus 3y. Now I'm going to move to the second set of parentheses. I have my y squared, and now I'm going to remove y squared from each of these. So I have 4x y squared over y squared. So the y squareds completely cancel. So I'm just left with that 4x. And then I have 3y cubed over y squared. So I'm going to have 3, and then subtract the exponents top minus bottom. 3 minus 2 is 1, so I have a single y. Now you know that you've done the process correctly when inside parentheses they match. So both sets of parentheses are identical. I have 4x plus 3y in both of those. So when that matches, when we have that in both terms, that means I can factor that out. So I'm basically factoring out the 4x plus 3y, and that goes in front. And then what's left over is the greatest common factor. So I have an x squared plus y squared. So those things that ended up in front, those become your second set of parentheses. So you're kind of moving things around, and you end up with two things multiplied together. That's the ultimate goal here. So our final answer is 4x plus 3y times x squared plus y squared. So your first set of parentheses is what matches. The second set of parentheses is what's in front. It's those greatest common factors. All right, so here I've got 4y squared plus 8y plus 7y plus 14. This is the sort of thing that you'll often see when you're trying to factor a trinomial. So you may notice that, oh wait, the 8y and the 7y are like terms. We want to add those together. If you add those together, so if we had a 4y squared plus 15y plus 14, you usually end up with something that you can't factor, which is we call prime if we can't factor that out. And I'm going to just think in my head, just verify that this is, yeah, this is unfactorable. So when you get something like that, that you can't factor, this is where we want to use the grouping. So we split it up so that you have, instead of one term in the middle, you split it up to two different terms. Now, if you watch my factoring video on the AC method, I talk about how you know how to split that up, how you know which combination of numbers that add to 15, like which ones to use. But this is just an example of, let's say that was already done, and now you've split it up into your two terms. So now we're going to factor by grouping. So you're going to group the first two together and the last two together. And then you're going to identify the GCF for each pair so that you can factor that out. So in a first pair, I can divide 4 and 8 by 4, and they both have a y, so I can also divide on a y. And my second pair, 7 and 14, I can divide those both by 7, but I can't remove a y because the 14 doesn't have a y.
You wrote prime up there. Are you talking about 14 being a prime?
This whole thing is considered prime. Yes. Because we cannot factor it as it is.
Right. Okay. I gotcha.
Yeah. So I am going to factor out my greatest common factor. So the first one's 4y. And then I'm going to write each term divided by 4y. And then you always have to have a plus in between these. A lot of people forget that plus is always there. The plus doesn't disappear till the final step. So until then, you always have that plus. So where am I? Okay, so I have my greatest common factor is 7. And then I take each term and divide it by 7. And then I'm going to simplify, so I'm going to do the division. So we have the 4 divided by 4, which is a 1. I usually don't write the 1 unless that's the only thing there. Y squared over y, your exponent on the y is 1, 2 minus 1 is 1, so you have a single y. Plus 8 divided by 4 is 2, and the y's cancel out. So we have y plus 2 in parentheses. And my plus 7, and then 7 divided by 7 is 1, and I'm left with a single y, plus 14 divided by 7 is 2. So again, the parenthesis parts match, which tells us we've done this part correctly. That means that, okay, we can keep going. And so this is the point where you get to your two sets of parentheses, and the first one is going to be the thing that matches. So what matches is y plus 2. So our first answer, or our first part, we're going to have y plus 2. And then the second part, which is the second set of parentheses, that's multiplied is what's in front, the GCFs, 4y plus 7. And so that is your final answer. So,
Got it.
Which actually, now that I'm looking at this, I shouldn't say that this is prime. We could factor it because we just came up with a factored part. But when you look at it, it's like I can't easily think of something. Like I couldn't look at it and think this was the combination that I needed to use to come up with that, which is why we use this other method, because I feel like there's less thinking, not as much like guess and check that you have to do here. Now here's one where we have negatives. So the last two that I've done have only had positives. So we haven't had to worry about the negatives. Negatives you have to be very careful with when you do grouping, because you can't just put parentheses and ignore the negative sign, because then you're changing what you have, because that negative really only goes with the 2p, not with the 1. So whenever I have something with a negative and that I'm going to factor, I rewrite each of those as adding, or if there's any subtraction, I have to rewrite it as adding a negative, and that avoids any possible sign errors that you may get. If you don't do that, you'll usually end up with things that are close, but they don't exactly match, and then that's going to cause you problems. So anytime you see subtraction and you're trying to factor, always turn it to adding a negative. It makes the grouping process easier. So I need to first find the greatest common factor of 2p squared plus negative p. So I can't divide a number out of a -1 and a 2. There's nothing in common there, but they both have a p. So my greatest common factor there is p. Now, in the second set of parentheses, if you have a negative in the very first term, you're always going to use a negative for your greatest common factor. So that's just a general rule. Whenever you're factoring something, you're taking the greatest common factor. If that first thing's negative, you always include a negative. So I'm going to have a negative, and then I'm looking, and between 2 and 1, there's no number in common. One term has a p, the other one doesn't have a p, so I can't take anything out. The only thing I can do is that -1. So the greatest common factor is -1. If that was a positive 2p, then your greatest common factor would be 1. You'd still have something written there. It would either be a 1 or a -1. And it's negative in this case because that first term is negative. So once you determine your greatest common factors, then you're going to actually factor them out. So the first pairing has a greatest common factor of p. So each term is divided by p. And then I have a plus. Oops, and I got to remember to actually write that -1. Then -2p divided by -1, and 1 divided by -1. So you have to be very careful with your signs, your positive and your negatives here, because if you get those messed up, it can mess up your answer. So I'm going to simplify. I have a 2p squared over p. One of the p's is canceled, so I'm left with a single p left. -p over p. So the p's cancel, but I still have that negative, so that's going to be a -1. Then I have plus -1. I have -2 divided by -1, which gives me a positive 2p. And then 1 divided by -1 is a -1. So you can see our parentheses match. If I had not taken out that -1, I would have ended up with a -2p plus 1, and then they would not have matched. So that's why we have to take out that negative if it's in the first part. So now from here, what is in parentheses, that is your first factor, 2p plus 1. And then what's in front of each parenthesis is your second one, p minus 1. And that is your final answer. All right, so I've got one more example. And let's see, yeah, making sure that I typed the right letters. When I have something where I have only letters, I'm always like, oh no, what if I wrote the wrong letters? Because then I can accidentally mess it up because, you know, hit the wrong key or something. So we have ay plus bx plus by plus ax. So we're going to do this by grouping. So we're going to group the first two and the last two. And then you want to identify your greatest common factor. So in the first pair, they don't have anything in common. There's no letters in common. There's nothing. So your greatest common factor is 1. And the second pair, we have the same problem. It's 1. So if we try to factor out a 1 out of both of these, it's not going to go anywhere. We're just going to get back what we started with. So what we do in a case like this is we can rearrange it using the commutative property. So that commutative property of addition allows us to rearrange. And we usually rearrange, we flip-flop the middle terms. So the bx and the by, I'm going to flip-flop those. So that gives ay plus by plus bx plus ax. And now I'm going to try to group. And now I can see that there are things in common now. Now I do have a greatest common factor. I can factor a y out of the first pair because they both contain a y. And the second pair I can factor out an x. So they do have a greatest common factor. And there's no reason why you have to flip-flop the middles. That's usually what we do. But if I wanted to, I could have rearranged and flip-flopped the bx and the ax and put the a parts together and the b parts together if I wanted to. So because these are all added together, you can rearrange the ordering in any way you want. Just conventionally we'll do the middle, but it really doesn't matter. So now that I know I do have something that I can factor out, I am going to do so. So my first greatest common factor is y, so I'm dividing ay by y and by y. My plus, my second greatest common factor is x. I have bx over x plus ax over x. And basically, the y in the first set of parentheses are going to be canceled out. So I have I have a plus b left over. And then I have my x. And then all the x's cancel, and I'm left with b plus a. Now, even though these don't exactly match, we have a plus b, b plus a, the commutative property of addition says that you can rearrange them. So they are the same. I can rewrite the b plus a as a plus b. So they do match. So now that we have those matching, we're going to do our last step of factoring where what matches in parentheses is going to go in front. So I'm going to have that a plus b in front. And then my greatest common factors are going to be the second set of parentheses, y plus x. And now that's the answer. So that's successfully factored. The trick here is that sometimes if it doesn't initially work, you can try to rearrange it to put things together that are similar or have things in common, and that will allow you to go through and factor.